Okay, guys, we gotta get started. Guys, we gotta start. Thanks. Let's continue. I mean, discontinue the chit chat. So, squaring radicals should be pretty straightforward. If you see a square symbol, whatever's inside the parentheses should be multiplied to itself. So if you have root 2 times root 2, you're allowed to actually multiply the 2 and 2 together and keep it underneath one radical. But of course, what's root 4? So you could just say 2. So what happens at the square root, whatever's underneath the square roots and squaring, it's almost like knock each other out, and you're left behind with whatever's inside the radical. That's really what's happening. Oh, sure, yeah. Take your time. You're good. Now, for up above, for B, you have root 2 up above. So it's root 2 times root 2 and 2 times 2. Right? You're just repeating it. Of course, that's root 4 over 4. And what's root 4? Well, root 4 is 2, and ultimately the final answer is going to be 1/2. That's ultimately the final answer. Very important, follow your order of operations. Follow PEMDAS. Can't stress that anymore. So parentheses, fine, but there's nothing in the parentheses I can combine. So I took care of the exponent. And then I multiplied root 2 with root 2, 2, 2. Then I did the division. Then I was done. But another thing you have to keep in mind, too, is that when I had root 4 over 4, you have to make sure you take care of that radical before you divide by 4. Very important. Because a radical, without realizing it, is actually an exponent. It truly is an exponent. It's actually a different kind of it's a fraction exponent, which you'll learn in algebra 2. But it is a fraction exponent. So make sure you take care of the radical before you divide. Now for C, you have 3 root 2. So you have to multiply. It'll be 3 times 3. Yeah, you got to repeat each one. So the whole point of the exponent is you're repeating whatever's inside. How many times I need the 3 to show up? Twice. How many times do root 2 to show up? Twice. So 3 times 3 is 9. Times root 4. What's root 4?
Together is 18.
Good. Well, you guys are on it. But I do want to make sure I'm moving at a good pace so all can follow. So it's good that you guys are able to see 2 or 3 steps ahead. That's awesome. More power to you. Do that. But if we want to be very deliberate, so we don't make mistakes. 3 times 3, root 2 times root 2. 9, root 4, 9 times 2, root 2. Root 2 times root 2 over 2 times 2, that's root 4, root 2, 4. That's 2 over 4, that's 1/2. And of course, root 2, root 2, root 4, that's 2. So now, what do you guys think about D? Keep going. That was a little awkward. Okay, just kidding. There you go. You guys said at the same time. It's kind of cool. All right.
4 times 5. 25. Wait, yeah, over 9.
Mhm.
And then it's 20 over 8.
Yeah, and then root 25 is 5. So you should get 20 over 9. So if you think about it, you square into 2, you square into 3, you square into root 5. So once you get very good at it, you can just see, oh yeah, it's 4, 5, 9, 29, right? Once you start moving more quickly. So that's going to be 4 times 5 over 9, which is, of course, 20 over 9.
So what? How about
Okay, all's good? Oh, never mind. We'll wait. I'll freeze the screen. Okay, moving right along. Now, simplifying radicals.
It's 20 divided by 3.
6.666.
So what if you did?
Okay, Ray, can I move on?
Yeah.
Okay, thanks.
What if you did like 6.7 over 3?
What do you mean by that?
If you simplify 20 and you divide each by 3, you got 6.7 over 3.
Well, no, that would be just it would just be 6.7 added 3 times. Well, where do you get that from?
Could you simplify 20 over 9?
Just leave that alone. That's fine. Oh, I see what you're saying. No. You want to leave it. No, you want to do what 20 divided by 9 is. I don't know what that is. It's like 2 point something. It's like 2.22, I think. You don't want to break that apart. Where you're trying to break it apart is 20 over.
Trying to break it apart.
You can't, the denominator has to stay the same. You could do like 10 over 9 plus 10 over 9. You can't, were you doing like 20 thirds plus 20 thirds plus 20 thirds?
I was doing like divide each by 3 to like simplify the fraction.
Oh, I see what you're saying. Oh, I see. Oh, I got you. Yes, you can do that. Yes. Yeah, you can. Yeah, you can. Okay, I'm gonna give my voice a little break, and also so you guys can stay a little more focused. Colette, can you read the top simplifying radicals, please? Yeah. Yeah, so if you did root 2, that's 1.414 ... I have those digits memorized. I don't know the other digits that follow, but it's a really weird number. Yeah, it's like 1.414213562. So we say that's not rational. And what that means, well, first of all, let's talk about what rational means. Does anyone know the definition of a rational number? I know you guys learned in middle school. I think you did. I could be wrong. Anyone know a rational number, how that's defined? Kira, do you know?
I have no idea.
Okay, I'll tell you guys. It's a really simple. It's kind of a play on words. It's a ratio of 2 integers. That's a rational number. Okay, so a ratio of 2 integers. So for example, 0.5. What 2 integers can I divide to get 0.5? Or what fraction can I make with that 0.5?
1/2.
Yeah, 1 over 2. 1 and 2 are both integers, right? Remember, integers are whole numbers, but you can include negatives as well. What about 0.3 repeating? What's that as a fraction? That's a rational number. But some numbers are not. Pi, root 2, non-perfect squares. Those are not rational numbers because I can't write that as a fraction. So those are things that have decimals that could move on forever, or well, actually, not supposed to move on forever, but they just have no pattern to it. There's no pattern. So there's no pattern in root 2 or root 50. So it goes on forever without repetition. So no repetition, no pattern. Like that would be that ... So exact answers, that's precisely what it means to be exact. They're not rounded or changed in any way. They are what they are. These are all considered exact answers. So 7.2, and that says nothing to follow after that. 1/3, root 2, pi, and so forth. Now, approximate answers would be if you're rounding these. So 7.2 would be the approximation of this. Well, actually, the approximation of this if it were that number. 0.3 is an approximation of this because truly 1/3 is 0.3 repeating. That should be 0.3. And you guys know what that means? We put a bar to. Keeps going. Good. Okay. Yeah, that's an approximation. Pi goes on forever. But 3.14227s are approximations of pi. So be mindful of the wording. So for example, actually I'll do this because I'm recording. Say I gave you something like this here. Pythagorean theorem. Ask you to solve for C. So first of all, how do I get this set up? What's the first step? Go, Faith. Correct. And if I work it out, I should get 34. Now, if I ask for an exact answer, that's what I mean. And we are going to be very particular about this on our next test. So if I ask for an exact answer, leave it in radical form. Don't touch it. Leave it alone. Root 34. If I ask for an approximate answer, I want you to round to like say 2 decimal places. I'm going to punch in root 34 on my calculator. I get 5.83. Now 5.83 is an approximate answer. rounded to 2 decimal places. So if I ask for an approximate answer, let's do that. If I ask for an exact answer, don't give me a decimal. Leave it in radical form. Of course, if you can simplify it, do simplify it. Faith, go ahead. Right. If I asked you to simplify, we would. Right. Like root 50, for example, I know is 5 root 2. If I asked you to do that, then do that. I'd say exact. Root 50 is exact. That's simplified. So I would say exact answer and simplified. I put both. Yeah, we try to be as explicit as possible so there's no vagueness. All right, let's keep moving. All right. Next up. Okay, so you guys should be pretty comfortable with this, hopefully. So what we want to do is break these apart into a product of numbers where one of those numbers is a perfect square. Meaning when I square root it, the answer is a whole number. So what factor of 50 would be a perfect square? You can do 5 and 10, but I would actually do 25 and 2, yeah. So it becomes 2 root 5. No, sorry, 5 root 2. Because you're rooting 25 versus 5. That's why. Yeah, actually, to clear that break. No, actually, I'm glad you brought that up because I didn't think of that. Here's what's happening. It's the same thing as saying this. This will help clear it up. So it's 25 times 2, right? Correct. So you get 5 root 2. All right, let's keep going here. Yeah. 50 is a product of 2 numbers, 25 and 2. So
Wait, if you like came up with 50 and 1 or like another.
it doesn't help us because it's just root 50. You want to find a number that's not 1, because 1's always a perfect square, and all numbers are divisible by 1. We want to find something that's not. So let's try another one here. Someone give me a perfect square. Yeah, 300. Very good. So if I do root 100 times 3.
What if you use 150 times 150? Oh wait, sorry, 150 times 2.
Yeah, but those are not perfect squares. You want perfect squares. Now, if you ever get stuck, say for example, you did 8 and 9, which could work, but you could also break them down like this, 3 and 3. So I'm not sure if you guys seen this before. It's called a prime factor tree. So when you're square rooting, you want 2 equal roots. So 2, 2, 3, 3. That one doesn't pair up. These 2's pair up. These 3's pair up. And why am I pairing up? Because it's a square root. I need 2 equal roots. So that's 4 and 9. Well, what's root 4, 2? What's root 9, 3? So if you want, you could, it's a little long-winded, but you could write like this. 2 times 2 times 2 times 3 times 3, which is the same thing saying root 4 times root 2 times root 9. That'd be the same thing as saying 6 root 2. It's a little long-winded to write that, but you can. Personally, I prefer when you get really good at this, just do 36 and 2. And what's root 36? But if you ever get stuck, you can always break it down to their smaller components, basically their prime factors, and then we figure, oh, 2 times 2 is 4, that's root 4. 3 times 3 is 9, is root 9. That's 2 and 3, 6, 6 root 2. So you could do that. But if you see the factor, it makes it easier. Now let's look at A4. Faith, go ahead. Times. We're not adding. We're multiplying everything. I can't, if it's addition, I can't even break them up that way because that would disobey the order of operations. But for multiplication, I'm allowed to do that because a radical is like an exponent. Like, for example, if I have 2 times 3 squared, I could totally distribute that exponents. It's kind of the same thing. What factor of A4 is perfect square?
Um, 4,
4. 4 times what?
21.
So you have 2 or 21,
Yeah.
but not perfect squares. But what you do is take the 42 and break that down further. That's 21 and 2. Then you'll see you have 2 times 2. So if what you're doing, that's fine, but keep breaking it down. All right, so now with that, I think you guys could handle these. So go ahead and try these here. You have a list of perfect squares off to the left to help you out. I will work this out, and then we'll stop there because we do have to get the project started. And we could do more of this on another day. But what I want you guys to do is 1 through 12 in your table groups. Go and simplify 1 through 12. I'll come and help you guys out. And then we'll start the project after that. And also in the meantime, I'm gonna put the pairs for the project on the board. So I'll put the partners as well. So go and work on this, guys. I'll come around and help you guys out.
May I go to the bathroom?
Sure, it's fine, yeah. Some of these might not be simplified. Just keep in mind.
And then.
Jeez.
Yeah, it's just cool. It goes, well, it goes like this.
Yes. It's got it.
Turn it off.
Yeah, that's what you're looking for. You're trying to find. What you want to very.
I got.
Five. Okay.
Yeah. Five.
Yeah, I know you know you.
Yeah. Or would you actually do it? And then you do. Yeah.
So that'll be 2 root 2. Because root 4 is 2. So put it this way,
Yes.
when they pair up, right? So the 2, you have a pair of 2s. Pull it out. What's up behind? An extra 2. So it's 2 root 2. Because you're doing root 4 times root 2. And what's root 4? Yeah, guys, when you're breaking it apart, you want to square root a perfect square. And then after you do that, then you give it a.
So we can use this. Right, and that's.
Do you want to shoot it again?
Eight, 80?
Yeah, put them aside.
You could do that, but then it's a little weird because those not from squares, but 10 is 2 and 5, and 8's 4 and 2.
Yeah. Okay, what else?
So I'll do the board. So,
Three.
so maybe 10. So nothing wrong with that. That's 4 times 2, and that's 2 times 5. So you have 4 times 4 times 5. What's root 4?
2,
What's root 4?
2, so 2 times 2 times 5? 2 times 2 times root 5, okay.
It's 4.
That's what I got.
Or you can do 16 times 5 right from the beginning, but if you can't see that right away. You can't do it right away. What you're doing is fine.
Drummer.
Basically, you're regrouping numbers essentially. That's what you're doing. You're trying to find groups of numbers that multiply, but then you want to land on a group where you can square root some of these clean ones. Root 5 I can't do cleanly in my head. That's kind of a weird number. Root 4, I could. Are you familiar with that concept? Any other one?
5 or 3, 6 or 6.
So we'll play musical chairs in a little bit. No. Figure of speech. Yeah, so you guys could just move seats in not right now, but in a moment. All right, here we go, guys. Let's talk about the answers. All's good?
Yeah.
We're not good with talk, not good, it's okay. So for number 1, that's 5 root 3. 25 is a factor. 75 divided by 25 is 3. 2 is pretty straightforward, and 4 is pretty straightforward. 3 is straightforward. 6, yeah, there's no perfect squares. That's 2 times 3 times 5. I can't do anything about that. For 5, 16 times 5 gets you 80, so root 16 is 4. For 7, 4 times 2 is 8, so you get 2 root 2. 8, you can do 9 root 2. Sorry, 9 times 2, so 3 root 2. For 9, you can do 16 times 2, which is 4 root 2. For 10, you can do 4 times 3, so 2 root 3. 11 is a tricky one, but if you do look up into the table, 144, that's half 288, so you get 12 root 2. Lastly, yeah, not super easy, but 108, your break apart is 2 and 54. 54, your break apart is 2 and 27. So the way I sometimes deal with ones that are a little more challenging, like root 108, I kind of tell myself, well, that's 2 and 54. That's 2, maybe 9 and 6. 2, 9. Yeah, you can do 16, 36 times 3. But as I rearrange them, I get 4 times 9 times 3. So I could do root 4 is 2. I could do root 9 is 3. 2 times 3 is 6, so I get 6 root 3. So you're trying to really use a lot of number sense as you approach these problems. Okay, I'd love to do more of this, but we do need to get the project started. So correct, yeah. So let's just talk about the project first. Let's read through parts of it so everyone understands the parameters. Then we'll get started, and we'll dedicate class time next week as well. So you guys have time to do that. So let's pull up the project. Okay. Lucas, can you read the opening part of the cool project?
This opening is inspired by the quote study in Hidden in Plain View. The secret story of quotes in the Underground Railroad. The idea that to leave a hostile part of the country where hostility was sanctioned by law. People utilize patterns to convey discrete messages and ensure that law enforcement cannot interpret and interpret their code. Each pattern communicated something important for the survival of citizens seeking safety in the southern United States.
So that's just the history behind it. It's kind of neat. A little bit of social justice happening there. But of course, now our task is to do the math and geometry. Ale, can you read the next part? It says your assignment. This is a partner project. Okay, so yeah, it makes sense. So it's a team effort, not individual, right? We don't want one person pulling the weight for the whole group. So make sure you're being mindful that everyone's pulling their own weight. And then we'll read the next couple bullet points. Peter, can you read the next one, which says you and your partner?
You and your partner will choose two shapes to utilize in the creation of the pattern in the quadrant assigned to you.
Okay, so you'll be assigned a quadrant and you will choose two shapes. Now the shapes you'll choose are presented on the next page. So you'll choose one from each row. And it's up to you. So you could do a square, rectangle, or isosceles right triangle, up to you. And you can do a kite, scaling right triangle, or isosceles trapezoid.
Just to be clear, it says choose one from each row and it says choose two shapes, but you have the option to do more than two shapes. So as long as you pick one green and one yellow, you can do others of those, any others of those shapes. So like if you look on this one here. We got a kite, we got a square, and we got a rectangle. That one chose three. You got, look at here and see what's on there. So it's, you gotta pick at least one from each of those rows.
And there is a portion of the grade that's based upon complexity. So yeah, you can see right here. So this is near the end. This is the rubric. So yeah, you make it more complex. That's good. Now we are going to talk about you could overdo it, and that might not be such a good idea because then it's going to take a long time to complete the project. So you want to have a nice balance.
Yeah, guys, I've done, Mystery hasn't done this, is partly why I'm in here right now, is to kind of help you introduce you to it, but I've done it for a number of years, and the more shapes you put on, you can make it prettier, you can make some, students have done some really cool patterns, but it also can create a lot more headaches, a lot more work for you, so you can overdo that complexity, so we'll try to give you a warning if we think that you're overdoing it, but still, it's kind of fun to put more than just two shapes.
Okay, now the actual stuff we have to do. So part one, Mag, can you read part one?
Draft of initial quadrant design due to September 23rd, Wednesday, September 24th, and Thursday.
So for us, that will be Tuesday. So we'll have time in class on Monday to work on it. And initially it's just you're doing the just the drafts. Like that's something we could totally do in one day. Is that correct?
Yeah.
Yeah.
Yeah, I mean, you probably won't get it done today, but you'll be able to get it done in the next class. It's just a sketch.
Yeah. So Monday we'll have time because I'm not going to do much learning with you guys. We're just going to do, or sorry, well, we're always learning, but we're not doing much lecturing on Monday because I want you guys to work on this. Then what we're going to do is the following. So Sabian, can you read the next part? Says apply two different. So if you read the next part.
Identify and state the slope of the line of reflection. The reflected image must stay fully within the assigned quadrants.
So if we look at like this one, this is an example, and this is where Mr. Davis probably could help me out so I can understand better. So this is clearly in the second quadrant, and I assume the initial shapes were the kites and the isosceles right triangle.
Yeah, so that one only has two shapes. And we're only, for right now, all you guys are worried about is doing the one quadrant. You're staying, everything, even reflections and translations, is all staying in one quadrant. So one of these boxes, your last sheet has graph paper on it, which has these boxes. You want to stay inside the box, but you can say like, okay, I started off with, let's say this isosceles right triangle and this kite. Okay, how did I get from this triangle to this triangle? What does that look like? What did I do? That's a reflection over what? Over
-6.
yeah, x equals -6. And so whenever you have whenever you're doing a reflection, you got to name that line of reflection and name the slope of that line. What's the slope of the vertical line?
0.
No. That's 0. That's undefined, right? Undefined. Slope of 0. Okay, so so that's a reflection, and then let's say, how did I get from here to here?
Translation?
Yeah, translation up and over or over and up, right? Yeah, this is your X, this is your Y, right? How about here to here?
Reflection.
Reflection, right? It's a reflection and what over what line? That's a diagonal line. Little more complex, okay, you get a little more pop for your complexity, and you gotta find the equation of that line, which is a little bit more complex. It's gonna be a slope of -1, and you can figure that out, and you can see where the,
Spot.
right, so you can figure that out. And then like these, you could either be reflections or translations, some things could be either reflection or translation. But you're only staying within quadrant, you're only doing pencil graph, and you wanna identify your coordinates too. So when you're doing the reflection or the translation, you're gonna find the new coordinates. And you're gonna identify your shapes with like A prime, B prime, or A, B, C, D, and then A prime, B prime, C prime.
So is there no locations?
We'll do in a moment. We'll get to that. So, so we translate as well. And if you look at the second bullet point, left, right, up, down, whatever you want to do. And reflective shape must stay within the assigned quadrant. Optional, but recommended, you can perform additional reflections and or translations to your respective shapes to complete your desired pattern. Be responsible for accurately reporting any additional transformations you perform. So you can make it more complex, as Mr. Davis said, and record all of them in the initial quadrant clearly. So use prime notation like A prime, B prime, or double prime, triple prime, quadruple prime, and so forth. And make sure you identify whatever reflections you did and the slope of that reflection. So as Mr. Davis said, verticalize the slope of undefined, horizontal slope of 0. If you do slanted, it could be slope 1 or -1. So that's your initial quadrant. But now here's what happens. So Mag, you asked a great question, right? So Connor, can you read the part versus once your initial design?
Once your initial design is approved, you will receive larger graph data to complete your project.
Yeah, and that's gonna be much later. That'll be after the initial ones do. Probably not till after our tests, I assume. We'll
We might have a day before.
yeah, maybe the day before. Yeah. So that'll be much later. No, Monday after. Yeah. Yeah, no, we're we got some time. And you can rotate however you like. William, can you read the third bullet point at the which says you will rotate?
Please, 270 degrees, either clockwise or counterclockwise, either side. Thus filling your entire graph with your assigned pattern.
So you can see like, those are all rotated, like they're all the same for the most part in each quadrant, but they're rotated. And so you have to
Or the other way.
Other way, it's up to you. Yeah. But we'll worry about that later. That's gonna be much later. So for now, what I want you guys to do is find your partner. You do have just so you know, you have graph paper near the end. Now the quadrants, do any side of the quadrants?
We'll go talk to you about your shapes, on page 2, there's a place to write your shapes. And we'll talk to you about the quadrant. We'll pretty much let you pick your first quadrant, but you can pick which one you want to do.
Yeah, so it's just
Start at 1, 2, 3, or 4.
Wait,
All right, good luck.
so we got one group of 3, everyone else is paired up. Pierce, probably easier you move. Yeah. And then Sabine and Cam, I guess we're moving. Yeah, so figure out what you want to do.
I was scared. I know that I have a map. Yeah, both of them.
Where do you want to put it?
You don't have to worry about color or anything now, or outlining. All we're talking about is shapes now. Do the math part.
I can't look at them. I'm gonna show you how. And I'm gonna get mine done because you got your.
Remember, you can pick and optionally. They want to pick, but
This is your checklist. It's online. So your monster shape you want to do, put it on there, label it, and then start reflecting, start translating.
Alright, so walk in.
They do that shape that's on the.
Yeah, it says me just. Come on, I see the bird.
Your brother's brand.
Yeah, it's brother. This is just like small.
I'm sorry.
I think you do it. I think you do a right triangle. Right. Not practice. Yeah. Practice.
Whatever you guys.
Rectangle, triangle, and square. Rectangle, triangle, square.
I never worked around. I like some of the practice. Where.
So, square, rectangle, or. Okay.
Oh, there's also gonna be homework. Let me pass that out.
Wait, so we just choose what quadrant we want?
Yep, 100%.
You got it over here, guy.
Oh, I put it there, that's why.
Okay, we're ready, where would I like to start?
Just click your favorite slide.
Bottom, top. Two,
When we start top left.
Write it down.
Ooh, I love
And then.
And the next handout you're getting is the homework. That's due on Monday morning.
Wait, we do, I saw see.
Wait, where are you going? What are you doing? Oh my god, no show.
Oh, wait, no.
Okay.
Yeah, it's just.
But I gotta see. Yeah, and then you just you put your name here. But
I
then work in that quadrant, then you'll see it there. By your first, so you can square what else? Right, great. So, but obviously make sure you guys are all, you know, sounds good, same.
You add.
What do you want for the square?
Yeah.
No, I was. Yeah.
Where we find the eyes.
Two.
The shapes can't be too small.
Write it, the right hand one.
Yeah, we're not, it's not that, so.
There's a lot more things.
It's not that.
Right now, it's the right.
Try to do that.
Yeah.
What period do you test?
I go back. Hey.
It's like they're having it here, I would love
And then, once it's late, we're in cluster, so we're inside. Stay with the then start, new squares, new heights, like you wanna be, I pick a quadrant, by you move.
So it's sort of.
So like, so an example of, but again, for example, the bars.
Oh,
Doing a triangle, triangle. Oh, okay. Oh, good. You'll actually, you'll be more creative. Yeah. You guys,
If you're using kite, remember the definition of a kite. Kite is not a diamond. One side, two legs of the kite are longer than the other two legs. All your drafts have to be signed off by Mr. E or me. Before
But we're gonna spend most
we
of our
got time
time
next week, so we're not finalizing anything today. You guys are just starting the process.
Okay, I did it. Yeah, the center. It's exact center. One, two, three, four, five. 1, 2, 3, 4, 1, 2, 3, 4.
Remember, if you're moving them around, you have to. If you have multiple shapes, how did we get there? Translate, rotate, or not translate or reflect?
Of course.
Translation.
Right.
Where's other one?
Different, right? It's, it would have to be. Yeah, go eight to the right. And then.
Oh, eight to the right.
Eight to the right, and then.
5, 5, 11. Build it around that. It's which way? 11. Oh, wait, or like in part of it. So should we translate? Right. Like, wait, where do you put the oh, where we know we're gonna
Which if you guys know this.
Yeah, we're doing.
Square, rectangle, and triangle.
Make it.
Yeah, they just translate like this.
Or is that-
Like two.
No, stay in the box. Oh, you can do as many as you want.
2 minutes. Yeah, 2 minutes.
Oh, sorry, 2 minutes. Yeah, well, yeah, one of each.
Four of them, that done.
Okay.
But, and again, don't worry about the other one.
You guys just scratch the surface.
Yeah.
Definitely.
Yeah.
If you start there with your initial
Weekend,
shape,
can.
what are you gonna do? Reflect or rotate or translate that? And where would you end up?
Reflect it right here.
That would go over, wouldn't it?
Yeah, you gotta be careful it doesn't go in the box.
Yeah,
You have to reflect one of the shapes and you have to translate it weekly with this.
Translate this and then reflect the rest. And we'll-
Okay, but if you translate it, so,
We're gonna translate it up and over and up.
and
So do that, like, started after.
you're gonna overlap them,
Yeah. this is good to out on.
like a square, this square
No,
has to over, if you're gonna translate, it can't go outside the box. So it's gonna overlap, and which is fine, you can overlap if you want, but you see how, you know what I'm saying?
And then translate and do a rectangle on this part.
You see what I'm saying about the square, like the size of it now.
Because there's like this set. Let's talk about it.
But you could do it like 4x4 square in the
Yeah,
square,
let's do
or a 3 by
You
3.
guys, bell's about to ring, start packing up. No, we're gonna work on class on Monday, so don't feel pressure. That's you.
But you can Google over the weekend.
Think of ideas,
Yeah.
look around you, out in the world. See what
Part of this project, guys, is working with teammates. That's part of the learning, learning how to work with the team.
Have a great week, everybody. Yeah.
I hope your car gets better. We're praying
The
for
car's
that.
total, I know, that's.
But,
No, what's probably gonna happen, I'll prepare my rental car, I'll borrow my mom's car, she's got a nice Mercedes. Exactly. She doesn't drive anymore, my dad drives.
Pray that you win.
But I would.
Yeah, we're gonna pray that you win a lot.
That's okay.
Yeah.
I'll just save up and I have money.
Let's go. No, you. I have the tickets to the lottery. We don't like
You can, you can throw me in that for too while you're at it. We'll cover you if you.
I also need that most powder related. And actually, I'll do for my.
Show me that.
period.
Yeah.
So is this for you or do you need it? Yep. Oh, therefore. All right. Okay.
I think so, yeah.
I also.
Are we sure? Okay, I have to go with English cafeteria. No, I have to go back to my side.
That's.
See you later.
Yeah. So you're over.
That's not.